Subscribe for more videos. Welcome to our exploration of the science behind extreme weather. This is a journey into the thrilling and sometimes terrifying world of nature's most powerful performances. We're talking about hurricanes, tornadoes, heat waves, and more, each with its own unique set of characteristics and challenges. These extreme weather events are not just impressive displays of nature's might. They have a profound global impact. They can ecosystems, devastate communities, and reshape landscapes. Yet they also inspire awe and wonder, reminding us of the raw power that nature holds. Understanding these events is a fascinating mix of science and curiosity. It's decoding the secrets of the atmosphere, the oceans, and the Earth itself. It's about appreciating the delicate balance that makes our planet so wonderfully diverse and dynamic. As we delve into the science behind these phenomena, prepare to be amazed by the power of nature. Imagine a storm so powerful it can flood cities and flatten buildings. This is the reality of hurricanes. Let's embark on a journey into the heart of these devastating weather phenomena. At the very core of each hurricane is a simple yet fundamental principle of science: the transfer of heat energy. The story begins over the warm, tropical ocean waters, where the temperature is at least 26 degrees Celsius. Here, the heat from the sun warms the water, causing it to evaporate into the air. This warm, moist air, full of potential energy, rises, creating an area of low pressure beneath it. Now, air always moves from areas of high pressure to low pressure. So as our warm air ascends, cooler air rushes in to fill the void. But as it does, something curious happens. The Earth's rotation causes this incoming air to spin, and a cyclonic storm begins to take shape. As the warm, moist air continues to rise and condense, it forms towering clouds, releasing heat energy in the process. This heat energy powers the hurricane, driving its destructive winds and torrential rains. At this point, you might be wondering, how do we measure the intensity of these formidable storms? This is where the Saffir-Simpson scale comes into play. Named after the engineers who developed it, the scale ranks hurricanes from 1 to 5 based on their wind speed. A Category 1 hurricane with winds of up to 95 miles per hour can cause some damage. But a Category 5 storm with winds exceeding 156 miles per hour can result in catastrophic destruction. Understanding the science behind hurricanes can seem daunting, but it's crucial in our fight against these extreme weather events. By comprehending how they form and intensify, we can better predict their paths and potential impacts. We can prepare, respond, and ultimately save lives. Understanding how hurricanes form is the first step in predicting their path and potential impact. From the tranquil to the terrifying, let's turn our attention to tornadoes. These monstrous whirls of wind are more than just a spectacle. They are a formidable force of nature. Tornadoes are born from thunderstorms, but not just any thunderstorm. They originate from the most powerful of them all, the supercells. Supercells are like the elite members of the thunderstorm family, possessing a unique feature that sets them apart: a rotating updraft known as a mesocyclone. This rotation is key to the birth of a tornado. But how does this happen? Well, when warm, moist air near the ground rushes up to meet cooler, drier air above, it creates an unstable atmosphere. This instability, coupled with changing wind speed and direction with height, known as wind shear, sets the stage for a supercell. As the warm air rises, it begins to rotate due to the wind shear, creating the mesocyclone. If conditions are just right, a tornado can form. Now imagine a spinning ice skater pulling in her arms to spin faster. The same principle applies to tornadoes. As the air rushes into a smaller area, it spins faster, creating a powerful vortex. Tornadoes can reach speeds of over 300 miles per hour, making them one of the most intense wind events on Earth. So, how do we measure the intensity of these swirling giants? Enter the enhanced Fujita scale, named after Theodore Fujita, a pioneer in tornado research. This scale rates tornado intensity based on the damage they cause, ranging from EF0, where damage is light, to EF5, where damage is incredible. The scale gives us a glimpse into the destructive power of tornadoes. While tornadoes can be deadly and destructive, they also provide valuable insights into the dynamics of our atmosphere. They remind us of the tremendous energy that can be stored and released in the air around us. As we continue to study and understand these meteorological marvels, we strive to better predict and prepare for their impacts. Tornadoes are a powerful reminder of the energy that can be unleashed in our atmosphere. From swirling winds to scorching heat, let's now explore heat waves. Heat waves, unlike the tempestuous tornadoes or hurricanes, are a silent yet deadly phenomenon. So, what exactly is a heat wave? A heat wave is an extended period of excessively hot weather, which may be accompanied by high humidity. These events occur when high-pressure systems develop and hover over an area for prolonged periods, trapping heat and blocking other weather systems from moving in. Now, let's consider the science behind these high-pressure systems. It's all about the dance of air masses in our atmosphere. When air descends, it compresses and warms, creating a high-pressure zone. This warmer air mass prevents cooler air from infiltrating, effectively becoming an atmospheric lid. Underneath this lid, the heat builds up over several days, resulting in a heat wave. But why should we be concerned about heat waves? They may not tear roofs off houses or uproot trees, but their impact can be equally, if not more, devastating. Heat waves pose a significant risk to human health, especially for the elderly, the very young, or those with existing health conditions. Dehydration, heat exhaustion, and heat stroke are common during these periods of intense heat. Moreover, the effects of heat waves extend beyond human health. They also have profound impacts on our environment. Heat waves can exacerbate drought conditions, leading to water shortages and crop failures. They also increase the risk of wildfires, which can cause widespread destruction and loss of life. And let's not forget, heat waves are also a stark reminder of the ongoing climate crisis. Rising global temperatures mean that these periods of excessive heat are becoming more frequent and more severe, a trend that's expected to continue unless we take significant action to curb greenhouse gas emissions. In conclusion, while heat waves may not have the dramatic flair of a hurricane or the awe-inspiring power of a tornado, they are a force of nature that demands our attention and respect. Heat waves may lack the dramatic visuals of hurricanes or tornadoes, but their impact can be just as devastating. Now that we understand the science behind these extreme weather phenomena, how do we predict and prepare for them? The answer, in a word, is technology. As we delve into the 21st century, technology plays an increasingly pivotal role in predicting extreme weather and aiding in disaster preparedness. Let's start with satellites. These high-flying pieces of technology provide a bird's-eye view of our planet, capturing images and data that allow meteorologists to track weather systems across the globe. They can spot the formation of a hurricane in the Atlantic, a heat wave brewing over Europe, or a tornado twisting its way across the American Midwest. This real-time information empowers meteorologists to make accurate forecasts and issue timely warnings. Next, we have radar technology. Radar, an acronym for radio detection and ranging, is a system that uses radio waves to determine the range, angle, or velocity of objects. In the context of weather, it's used to detect precipitation, storms, and even the rotation within tornadoes. Radars give us a detailed, close-up view of severe weather, enabling meteorologists to predict its path and intensity with greater precision. Then there are computer models. These complex algorithms simulate the Earth's climate system, incorporating data on atmospheric conditions, ocean currents, and even the sun's radiation. By crunching vast amounts of data, these models can forecast future weather patterns and extreme events, from heat waves to hurricanes. But technology doesn't just help us predict extreme weather, it also aids in disaster preparedness. Geographic Information Systems, or GIS for instance, can map out areas at risk from natural disasters, helping authorities plan evacuation routes and emergency responses. Mobile apps can deliver real-time weather updates and warnings straight to our smartphones, giving us the crucial time needed to take protective measures. So, you see, technology is our ally in the face of extreme weather. It's a tool that, when wielded with understanding and precision, can make the unpredictable a little more predictable. With advancing technology, we're becoming better equipped to predict and respond to extreme weather. Our journey into the science of extreme weather has been a whirlwind of information. From the menacing hurricanes that churn in our oceans to the devastating tornadoes that ravage our landscapes, we've explored the sheer might of Mother Nature. We've seen how these weather phenomena are not random acts but a complex interplay of atmospheric conditions, energy transfer, and the Earth's rotation. The power of heat waves has also been examined, showcasing how even the silent, unseen force of temperature can have catastrophic impacts. But we've also discovered a ray of hope. Technology, the tool of our creation, stands as a beacon, helping us predict, depict, and even prevent some of the disastrous repercussions of these extreme weather events. From satellites in space to sensors on the ground, our scientific advancements are the shields against the storm, providing us with the knowledge and time to prepare and protect. Remember, understanding is the first step to preparedness. Stay safe, stay informed, and stay curious about the world around you.